This video will give you an introduction to the Python programming language. So I'm in my browser and I've gone to the CS2316 website. And if you want to follow along, you could load the slides for Intro to Python. All right, so I'm not going to follow these slides during this video, but feel free to do so. All right. Okay, so Python is a general purpose programming language. What that means is that you can write Python to write any kind of program. There are certain systems programs, low-level programs on a computer that you wouldn't want to use Python for. But when we say general purpose programming language, we mean that you can implement any algorithm in Python. This would be different from something like SQL. Or structured query language, which is a specialized programming language that is used specifically for manipulating data in relational databases, and that's something we're going to learn later in the semester. Okay, so before I dig into Python itself, I'll show you the Python website. So this website has lots of information. The main thing you're going to want to find on this website are the docs. If you look at docs.python.org, there's a tutorial and a library reference, and throughout the semester I'll be referring to this quite a bit. Next, I want to show you a few things that Python's good for. So Python, knowing how to program in Python and knowing the data manipulation techniques, file formats, data storage, and all that stuff that you're going to learn in this course will enable you to automate large parts of your workflow. And I'll give you a few examples from my personal work. So for one thing, if you go to my GitHub page, and look at my course tools repository, I got tired at the beginning of every semester of teaching of looking through the registrar's calendar and seeing when all the breaks were, when the first and last class days were, and all that stuff, and then creating a schedule by hand. Now, if you look at the schedule on the class website, go ahead and click the key combination to see the HTML code behind the schedule. You'll see that each day of the schedule has several lines associated with it. There's lots of nested HTML and stuff like that. It was tedious to generate that every semester. If I changed the schedule, I'd have to copy blocks of HTML code like this and move it around and so on. And that got to be quite tedious. So what I did is I created a set of Python scripts to automate that for me. I wrote a program called makeschedule.py that takes in the first and last day of the semester that I got off the registrar's calendar, the breaks, which is a JSON file I'll show you in a minute, a JSON file that lists out the course contents, and that would spit out a file that looks something like this. And this is just a file format that I invented myself to be very convenient to modify the schedule. It's much easier to simply say, if I want to move the modules and programs lecture to a different day, I just cut this and paste it somewhere else and regenerate the schedule, and I'm done. I don't have to mess around with all this HTML, and when I used to do that, I'd inevitably forget some HTML closing tag or something, and it was a real pain. Now it's easy using these scripts, and that's because I can use Python. So as an example, we'll go to the command line, and I've got, for example, let's look at the fall schedule. Let's look at first cs2316.json, just the first 20 lines of that file. All right, so what does this do first of all? Let's talk a little bit about the command line. So cat, it would be type on Windows, simply concatenates the text file that you give it, or any file, to the console. So when I do this, so I say cat with the command line argument of cs2316.json. cs2316.json is a text file containing JSON code that contains all of the course materials for the course. You can see that it spits out a lot of information. How many lines are in the cs2316.json? Well, we can ask word count to count -L for lines, cs2316.json. Now, I don't want to look at 218 lines. I just want to get a sense of the structure of that file, so I can say cat cs2316.json. The vertical bar, we call that a pipe, and so we pipe that output through another Unix command called head, and I give it the command line option -N20, which says show me the first 20 lines of whatever I'm piping through the head command. All right. And so here you see a JSON file. This is what a JSON file. This is a dictionary, very much like Python because it's data enclosed in curly braces, and that is the fundamental data structure in Python. And then for every lecture, those identifiers that I showed you, in the schedule that gets generated, these correspond to these different entries in the JSON file. And so the topic, the materials, and so on, they get pulled out of this JSON file. And for every topic and materials and so on, you can have a list of things. You also notice that this syntax right here with the square brackets followed by the parentheses, that is markdown syntax for a link. So this is a very lightweight text format. CS20 or JSON is a very lightweight data exchange format. So I can easily put all the information into the JSON file. I can use very easy to read, low overhead markdown syntax together with Jinja2 templating, and I can easily generate this schedule file. All right, and during the semester, all I have to do is modify this schedule file, regenerate the schedule, and upload it to the course website. So there's an example of how I'm using Python. And the way it would look is something like, let's see, I'm hitting the up arrow to go back in my command history. So I would render the schedule. This says use the schedule stored in this file. That's this. It looks like this. Using the course materials from the CS2316 .json file, using this template for Jinja2, and using and then make the output be summer 2017 gtl.html. And if I do that, it runs and it generated that HTML file. So that's all I have to do. Modify that file, run this Python script, boom, done. Okay, so next thing I'll show you. I recently finished my dissertation. I had to collect a lot of data to analyze the Scala and Affable programs written by participants in a programmer study. So I collected all the data in these CSV files. So for example, complexity.csv and so on. As I was getting new data in, as I was modifying the way that I did calculations to do comparisons of means and calculate statistical power, create charts and graphs and stuff to put into my dissertation, I automated all that. So I have a script called, I have several scripts, but one of them is study results, which is a bunch of Python code that does statistical analyses and creates charts and graphs using matplotlib. And if I run that file, and again I'll just look at the head, so Python study results, let's pipe that through head -N20 again. So it does all these comparisons, and then it spits out LaTeX code. And I can pipe that LaTeX code into a LaTeX file and simply include it in my dissertation. So I get new data, or I change the way I do some of the analyses and so on. Then I just, I add data, maybe massage the script a little bit, rerun the script, recompile my dissertation LaTeX files, and I'm done. I'm not doing error-prone copy and pasting from, say, spreadsheets and so on. Again, a very productive computational workflow. Last example that I'll show you from sort of from my personal life. I'm a scuba instructor, and I teach for Georgia Tech Scuba, and I run certification trips down to West Palm Beach. Now, when you go down to West Palm Beach, one of the big draws is to go to this place called the Blue Heron Bridge. But if you dive at the Blue Heron Bridge, you need to dive at slack high tide. Divers know what I'm talking about. The rest of you, you just need to know that if I'm going to go diving on a specific day, I need to know exactly when the high tides are for those days. Or really what I need to do is I need to find out when the high tides are at the right time so that they fit with the boat schedule and everything else, and they're on weekends and so on. And then I need to plan my trips around that. So NOAA publishes tide tables, tide predictions for the entire year, and they update them periodically. Let me pipe that through. Head-N20. The default is for head, the default number of lines is 10, but that's not enough to really show the full structure. But this it's like 400 lines. No, it's more than that. WC-LW 17.text. Yeah, 1,400 lines. I could read through those 1,400 lines of tide prediction data myself to find out when the right tides are. Or I could use this Python script that I wrote. What did I call it? Find_tides.py. All right. And what this does is it reads that tides file and some command line arguments that I supply when I run the script. And then it just tells me which days have tides at the right time. So for example, I'm just going to go back in my command history by hitting the up arrow in my cursor. So if I run this command right here, what this says is find the tides in WPB tides 2017.text that are within the window of 2 p.m. to 6 p.m. And I chose that format. I personally prefer 24-hour format. I think it makes a lot of sense and it's efficient. But that's the way the tides are listed in the or the times are listed in the tides file, so I'm just going with that. So in that tides file, look for tides between 2 p.m. and 6 p.m. that are high tides on Fridays and Saturdays. And I run that script, and there you go. So if I want to run a trip that includes a West Palm Beach or a Blue Heron Bridge dive sometime between 2 p.m. and 6 p.m. on a Friday and Saturday, these are the candidate days throughout the year in which I can plan the trip. So again, very easy to do this. This is an example of what Larry Wall used to call virtuous laziness. Larry Wall was the inventor of Perl, which is a programming language that was sort of a forerunner of Python. Python solves a lot of the same sort of problems as Perl does. It's an interpreted language. It's a good glue language for doing data manipulation and having lots of different modules to do things like data analysis, file system tasks and stuff like that. And anyway, he said all great programmers have three properties: laziness, impatience, and hubris. And what he meant by laziness is that I don't want to keep doing a bunch of manual work every time I need to find tides or generate a class schedule or things like that. So I'm willing to put in a little bit of work up front to write a Python script so that the hundreds of times that I have to do this task down the road, I save a lot of time. And when you have the ability to manipulate data and use the Python programming language and so on, then you can really automate your life, and you can use the computer as an empowering tool. All right, so let's get into the Python programming language. Okay, so Python is, let's see. Python is an interpreted programming language. What does that mean? That means, I'll just turn on my writing tablet here real quick. That means that you create a file, right? Like, let's call this hello.py. And it contains some Python code, print, ... All right? And then you feed that to a Python interpreter. And you get a running program. All right? By contrast, a compiled language such as C you would create something like hello.c. You would feed that to a C compiler, like GCC for GNU C compiler. Actually, these days, people probably use Clang. And then you would get another file, which, depending on how you wrote it, would be just hello or hello.exe or whatever. And then that you can run directly by the operating system, and you get a running program. And just for context, because I know some of you are going to learn Java, Java is sort of a hybrid of these approaches. With Java, you would get hello.java, you would feed that to Java-C, which would create hello.class. Sorry for my writing. It's taken me quite a while to even get to the point where I can draw this monstrosity on this writing tablet. And then that gives you hello.class, and then you feed that to the Java program. And then that gives you the running program. Okay? Now, as you can see, this is a bit simpler than the others, all right? You just write a script and you run it, all right? So let's go ahead and show you how that works, all right? So we can get rid of this now. Let's save. Okay. So what I'm going to do is go first to my command line. So I'm going to go to my home directory, and then I've created a directory off of my home directory called CS2316, which is just a directory where I'm going to put demo files. I recommend that you create a CS2316 subdirectory, put subdirectories under that to hold your homework. For example, make dir hw0. Now you've got an hw0 subdirectory. If I look at my directory tree, I see I've got hw0 and sub1. I'm going to use rmdir for remove dir and get rid of that sub1 because I don't need that. and so on. All right, so in my CS2316 subdirectory, I've just got that one subdirectory of it, and I'm going to create a file called hello.py. I'm going to show you sort of the script mode of Python to begin with. So go over to Sublime Text. I already have that running. I don't like to use dialog boxes and stuff. I like to be very efficient when I'm programming, and so I've installed a package called IOpener. Later down the road, I'll probably make a video to show you how to customize your Sublime Text even further and to install some packages that make it even more productive. But when I say Alt-O, I can very easily notice that this looks down at the bottom here a lot like, if I were using the command line, and I can create a hello.py file. All right. Now, because this is a file that ends in .py, notice that Sublime Text says this is a Python file, and it's got Python down here. If I wanted to change the language mode, I could click on that in the lower right-hand corner and select something different. But of course, I want it to be Python. You'll also notice that I'll get syntax coloring, which will be more apparent when we write longer programs later. But let's write Hello World in Python. Ever since the publication of Kernighan and Ritchie's The C Programming Language, it's been customary for programmers to learn how to write Hello World as their first program in any new programming language. And all Hello World is going to do when we run it is write Hello World to the console. I'll explain what that means in a minute. In Python, that's just invoking the print function. When you invoke a function, you always do it with parentheses after the name of the function, as we've done here. And then I'm going to send an argument to the print function of hello, of a string containing the text hello world. All right. Now I can say Alt-S to save it. Notice that this is a dot. Do Control-S. Now it's an X. Okay, now at this point, I had contents in this memory buffer or in this editor tab in Sublime Text. Now that I've saved it, go back to the command line. If I do a listing now in my CS2316 directory, I see hello.py. And if I do a cat of hello.py, I see exactly the same contents that I see in my editor. All right. Now, to run a Python program, all I have to do is invoke the Python interpreter and give it the name of a Python script to run. In this case, it's just hello.py. And there we go. It prints hello world. All right. So that is the first way to run Python, is to put Python code in a text file that ends in .py. Now technically to run Python code as a script, it doesn't have to end in py, but be a good person and use a .py extension like everyone else. But a little bit later, we're going to learn how modules work, and modules in Python do have to end in a .py. So if you wanted to import a program, or rather a Python module, into another Python program or import it into the Repple, which we're going to see in a minute, then you need to have your Python code in a file that ends in .py. So we say that the hello here is the base name of the file, and the .py is the file extension. All right. Now, the other way to run Python code, and this is one of the coolest things about Python. These days, I won't even bother learning a new language if it doesn't have something called a REPL. And here's what a REPL is. If I run the Python command and I don't give it the name of a Python file to run, or I don't give it a command line switch such as --version to tell Python to just give me a version string, if I just say Python, then it starts up what's called the Python Interactive Interpreter, or Python Shell, or REPL. You'll hear me use all three of those terms. All right. And this is an environment where I can enter Python expressions at the three chevrons here. This is the Python prompt. And Python will give me the value. So, do I still have Art Rage running? No. So Repple stands for read eval print loop. All right. What that means is that what the interactive interpreter is doing is running this loop where it reads an expression, it evaluates the value of that expression, and then prints that value. So the most simple kind of expression in Python is a literal. So for example, 1 is the literal representation of an int value. And if I just say 1, that is an expression. It's because it has a value. Expressions are things that have values. Python prints out the value. 3.14 is another kind of value, which is a floating point value. We'll talk about that in the next lecture. And I print that out. 2 plus 2 is another expression that has a value, and it gets printed out. If I say print hello world, now a couple of things happened. One, print is a function that doesn't return a value. But in a sense, some people call that a void function and say it doesn't return a value, but the reality in Python is that, and we'll get to that in functions, is that functions always return values. But if you don't explicitly return a value, it returns the special value called none. And none doesn't have a string representation. So when we said print hello world, we invoked the print function, which printed hello world to the console, and then normally what would happen is that the value returned by the print function would be printed out, but nothing in addition to this console output was printed out by the REPL because none is returned by print. All right, we'll get to that more when we talk about functions, but the important thing here is that the Python REPL is a really, really wonderful tool for learning how to do commands. It's really nice to be able to run a command in the REPL to see how it works, and then say copy that code from the REPL into a script that you're writing. All right. Now to get out of the REPL, I can say exit. That works on both platforms. Now I'm back at the operating system prompt. All right. Now this is important. So a lot of times people are at one prompt or another and they sort of forget where they are. So like I'm at an operating system prompt. If I try to do some Python code here, then I get this syntax error because bash doesn't know what to do with that. So bash stands for born again shell. It is the name of the particular command interpreter that I'm using on my Mac OS install. All right. So I can't do Python things when I'm at the command shell, but I can do operating system shell things like get directory listings. And when I'm in the Python shell, I can do things like hello, print hello. But if I try to get a directory listing, ls is not defined. That's because I'm not in the command line shell, I'm in the Python shell. All right, so to get out of the Python shell this time, I'm going to go ahead and, instead of calling the exit function like this, on some platforms I can say Control D, and that exits the Python shell. Okay, so that is a brief introduction to the Python programming language. Of course, you should do this. You should have done this video after you did the Getting Started video. Now you know how to run Python programs, and you know how to use your editor to create them, and you know how to run Python code in the REPL. In the next video, we'll talk about values and variables in Python.